Hey everybody, today we're going to do graphing proportional relationships. Okay, this is often called direct variation, and I'm not really sure why they do this in a separate unit, but they always do. So what's direct variation? When two quantities x and y are proportional, the relationship can be represented by direct variation equation y equals mx, where m is the constant of proportionality. Okay, basically what this is nothing but a bunch of lines that go through the origin. Okay, so it's like y equals mx plus b. That's your equation for a line. It's just, notice there's no b, so b is 0, which means all these lines go through the origin. That's all this stuff is. Okay, here's your slope, there's your x, there's your y. So, right here, this is a graph of y equals mx. It's a line with a slope of m that passes through the origin. That's it. I can make this as steep as I want. I can make it do this. I can make it do this. Whatever. As long as it goes through the origin, we're good to go. Okay? So the cost y in dollars for x gigabytes of data on an internet plan is represented by y equals 10x. Graph the equation and interpret the slope. So they've gone ahead and graphed the equation right here. Notice that this is the data used and this is the cost. So 0 megabytes is $0. 1 megabyte is $10. 2 megabytes is $20. 3 megabytes is $30. So here's the graph. This actually answers the first part of the question. Graph the equation. And then interpret the slope. Well, what do I get out of this? Okay, well, I get that each is a gigabyte. Each gigabyte of data costs $10. That's how you interpret the slope. That's what the slope means. So basically, y equals 10x means if I know the number of gigabytes, that's going to be the x. So say I wanted 4 gigabytes. So I would plug 4 in here for x, and it's going to cost me $40. Okay, so the x is your gigabytes, and your y is your dollars. Okay? Piece of cake. All right. Found a couple of cool pictures that went with this. The weight y of an object on Titan, which is one of Saturn's moons, is proportional to the weight x of the object on Earth. So, an object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. Write an equation that represents the situation. Okay, here's a cool picture of Saturn, although you can see the ring barely right here, but here's Titan, and there's a close-up of Titan. Okay, so the first thing, remember, all of these are going to be y equals mx. Okay, so we got to figure out what m is. So I know that an object that weighs 105 pounds on Earth is going to weigh 15 pounds on Titan. Okay, so my constant proportionality is going to be the slope right here. That's going to be 105 divided by 15. Okay, so what is that? That's going to be, 15 goes into 105, let's see, 6 would be 90, that'd be 7 times, wouldn't it? Let's double check here, 7 times 5 would be 35, carry my 3, that, yep, sure enough, that's 105. So, y equals 7x, that's my equation. Basically what that means is an item weighs 7 times as much on the Earth as it does on Titan. Okay, so then, how much would a chunk of ice that weighs 3.5 pounds on Titan weigh on the Earth? Well, I'm just going to take 3.5, multiply that by 7. It's going to be 24, and have 1 decimal point. It's going to weigh 24.5 pounds on the Earth. And there we go. Okay. The distance y in meters that a four-person ski lift travels in x seconds is represented by the equation y equals 2.5x. The graph shows the distance that a two-person ski lift travels. Okay, so here's your two-person lift. This is seconds. This is meters. Okay, so in 2 seconds it goes 4 meters. In 6 seconds it goes 12 meters. Then you've got a four-person ski lift. Down here, here's your two-person one. Your four-person one, look at this. It's a little bit steeper right here. What does that mean? Well, on the blue one, which is the two-person, in 2 seconds it goes 4 meters, but the red one, in 2 seconds it goes 5 meters. So it's going faster. So the four-person lift, is faster. Okay, graph the equation that represents the four-person lift on the same plane as the two-person lift. Okay, so they went ahead and did that. And compare the steepness of the graphs. What does this mean in the context of the problem? So, what does this mean? Well, since this is a steeper line, the red one, the four-person one, is a steeper line, that means that the four-person lift is faster, which we had up here. Okay, and we can actually find out how much faster because we can look at a couple of points. So, like we said, here 2 gets you 5 meters here, and 2 gets you 4 meters on the other one. So it's about a half a meter. It's about a half a meter per second faster. 1/2 meter per second faster. Okay, so how did I get that again? Well, I know that in 2 seconds, the two-person goes 4 meters, and in 2 seconds, the four-person goes 5 meters. So it goes an extra meter in 2 seconds. So I take that extra meter, I divide it in half, and every second it beats it by a half a meter. And notice they're nice straight lines. It just keeps getting. So if I go out here at 4, here at 2, it was a meter faster. If I go out here at 4, it's 2 meters faster. The blue one was 8, and the red one was 10. Okay, so short lesson here. You're going to do 1 through 17 odd in class, and I will talk to you guys later.